Topic: The Great Dying. When life on Earth hung by a thread. Introduction: The shadow of the past. When we think of prehistoric apocalypses, our minds almost immediately drift to the image of a burning rock streaking across the sky. The Chicxulub asteroid, which slammed into the Yucatan Peninsula 66 million years ago, is the celebrity of extinction events. It has the drama, the sudden violence, and the famous victims. The non-avian dinosaurs. However, long before the T-Rex ever walked the Earth, there was another event. A catastrophe so profound and so thorough that it makes the asteroid impact look like a minor setback. Paleontologists call it the Permian-Triassic extinction event. But to those who study the sheer scale of the devastation, it has a more somber name: the Great Dying. To understand the magnitude of this event, we have to look at the numbers. The asteroid that killed the dinosaurs eliminated about 75% of species. The Great Dying, which occurred approximately 252 million years ago, wiped out 96% of all marine species and 70% of terrestrial vertebrate species. It is the only known mass extinction of insects. It was the closest our planet has ever come to becoming a lifeless rock, a sterile world drifting through the void. Today, we are going to peel back the layers of deep time to investigate what happened, why it happened, and how. Against all odds, life managed to claw its way back from the brink. The world. Before the fall. Before the chaos began, the world of the Permian period was vastly different from the one we know today. It was a time of consolidation. The Earth's landmasses had smashed together to form a single, immense supercontinent known as Pangaea. This colossal landmass was shaped like a giant sea, cradling the Tethys Ocean in its curve, while the rest of the globe was covered by the vast Panthalassic Ocean. Life in the Permian was diverse and thriving. It was not the age of dinosaurs, it was the age of synapsids, the ancestors of mammals. The land was ruled by creatures like the Dimetrodon, often mistaken for a dinosaur but actually a proto-mammal with a magnificent sail on its back. There were the Gorgonopsids, terrifying predators with saber teeth that sat at the top of the food chain. In the oceans, the reefs were teeming with life. Trilobites, the armored arthropods that had dominated the seas for hundreds of millions of years, were abundant. Sea lilies, brachiopods, and ammonites filled the waters. It was a stable, established ecosystem that had evolved over eons. But the geography of Pangaea itself laid the groundwork for trouble. The interior of such a massive continent was dry and arid, with extreme seasonal temperature fluctuations. However, life had adapted. It was tough. Yet, nothing could have prepared the biosphere for what was buried beneath the ground in what is now modern-day Russia. The trigger: the Siberian traps. The apocalypse did not come from the stars. It came from beneath our feet. The geological evidence points to a specific region: Siberia. Today, it is a frozen landscape, but 252 million years ago, it became the mouth of hell. It started with a mantle plume, a massive upwelling of hot molten rock from deep inside the Earth. This magma didn't just erupt from a single volcano. It tore open the Earth's crust. This event is known as the Siberian Traps Flood Basalts. The word traps is derived from the Swedish word for stairs, describing the step-like landscape the hardened lava created. But there was nothing orderly about the eruption itself. Imagine an eruption not measuring in days or weeks, but in hundreds of thousands of years. Lava covered an area of roughly 7 million square kilometers. To put that in perspective, that is an area roughly the size of the continental United States, buried under lava up to 4 kilometers deep. But the lava itself was not the primary killer. While it certainly destroyed the immediate ecosystem, a local lava flow cannot kill 96% of life in the ocean on the other side of the planet. The true killers were the invisible gases released by this geological violence. The atmospheric poisoning. As the magma rose through the Earth's crust, it didn't travel through empty rock. In Siberia, the crust was rich in coal deposits and organic-rich shale. When the magma burned through these layers, it acted like a match thrown into a fuel tank. It vaporized the coal and organic matter, releasing colossal amounts of carbon dioxide and methane into the atmosphere. Carbon dioxide is a greenhouse gas. We worry about CO2 levels today, but the injection of CO2 during the Great Dying was on a scale that defies comprehension. the global temperature skyrocketed. Estimates suggest that the planet warmed by 10 to 15 degrees Celsius. This was not a gradual warming. In geological terms, it was a sudden heat shock. The heat was just the beginning. The massive volcanic activity released sulfur dioxide and other halogens, creating acid rain that was strong enough to strip the land of vegetation. We see evidence of this in the fossil record. There is a phenomenon known as the fungal spike. In rock layers worldwide marking the boundary between the Permian and Triassic periods, pollen from trees and spores from ferns virtually disappear, replaced almost entirely by fungal spores. Why? Because the forests were dead, the trees were rotting, and fungi were the only things thriving on the decaying biomass of a dying world. The collapse of the oceans. While the land was burning and dissolving under acid rain, the situation in the oceans was even more catastrophic. The ocean absorbs carbon dioxide from the atmosphere. When CO2 dissolves in water, it forms carbonic acid. The rapid increase in atmospheric CO2 led to severe ocean acidification. For creatures that build shells out of calcium carbonate, like corals, brachiopods, and many plankton species, this was a death sentence. Their shells literally dissolved, or they could not form them in the first place. But the heat caused another, even deadlier problem: anoxia. Warm water holds less oxygen than cold water. As the global temperatures soared, the oceans lost their ability to hold oxygen. Furthermore, the extreme heat disrupted the ocean currents that circulate oxygen-rich surface water to the depths. The oceans became stagnant. The entire water column, from the bottom up to the shallows, became anoxic, completely devoid of oxygen. For the vast majority of marine life, this was suffocation on a planetary scale. The complex food webs collapsed. The trilobites, which had survived for nearly 300 million years through previous ice ages and extinctions, finally met their match. They vanished forever. The ancient coral reefs were wiped out, and it would take millions of years for reefs to return to the planet. The purple oceans and green skies. As the oxygen vanished, a new terror emerged from the depths. In the stagnant, oxygen-free waters, anaerobic bacteria began to bloom. Specifically, green sulfur bacteria and purple sulfur bacteria. These organisms do not need oxygen. They thrive in its absence and consume sunlight and sulfur. As a byproduct of their metabolism, these bacteria release hydrogen sulfide gas. This is a highly toxic gas that smells like rotten eggs. Models suggest that the production of hydrogen sulfide became so massive that the oceans turned a distinct shade of purple from the bacterial blooms. The gas didn't stay in the water. Enormous bubbles of toxic hydrogen sulfide erupted from the ocean surface and drifted over the land. Imagine standing on the shore of Pangaea. The ocean is purple and oily. The sky is a hazy green from the mixing of gases. The air smells of rot and sulfur, and that air is lethal. Hydrogen sulfide is toxic to plants and animals. It destroys the ozone layer. This gas attack from the ocean dealt the final blow to the terrestrial survivors that were already struggling with the heat and the loss of food. With the ozone layer shredded by the halogen gases and hydrogen sulfide, ultraviolet radiation from the sun blasted the surface, causing mutations and death to anything left exposed. The struggle for survival. It is difficult to overstate how close life came to total annihilation. The devastation was so complete that for a long time, there is a gap in the fossil record known as the coal gap. For millions of years after the extinction, no coal formed because there were simply no forests left to create it. So, who survived and how? Survival was a matter of luck and specific adaptations. In the oceans, creatures that could tolerate low oxygen levels or lived in the very shallowest, most turbulent waters where some oxygen remained, managed to hang on. Some simple bivalves and crustaceans burrowed deep into the mud to escape the toxic water column. On land, the large specialized predators and herbivores died out. The survivors were generally small, unspecialized burrowers. Living underground offered protection from the extreme heat and the ultraviolet radiation. Scavengers fared better than picky eaters. One of the most significant survivors was a creature called Lystrosaurus. It was a pig-sized herbivorous synapside with a beak and 2 tusks. It wasn't pretty, and it wasn't particularly smart, but it was a master of survival. In the immediate aftermath of the extinction, The world was so empty that Lystrosaurus took over. For a brief period in the early Triassic, this single genus represented a huge percentage of all terrestrial vertebrates on Earth. It is often jokingly referred to as the animal that inherited the Earth, simply because everyone else was dead. Another group of survivors were the archosaurs. These were small, agile reptiles that would eventually evolve into crocodiles, pterosaurs, and the dinosaurs. Their respiratory systems were more efficient than the synapsids, allowing them to extract oxygen more effectively from the oxygen-depleted atmosphere. This biological advantage in the post-apocalyptic world likely set the stage for the dinosaurs to rise to dominance in the ensuing geological periods. The long road to recovery from the Great Dying was painfully slow. After the asteroid impact that killed the dinosaurs, the planet's biodiversity bounced back relatively quickly, within a few 100,000 years. But the Permian-Triassic extinction was different. The damage to the carbon cycle and the global climate was so severe that the Earth remained unstable for nearly 5 million years. During this early Triassic period, the Earth was a harsh, hot, and unpredictable place. There were repeated spikes in temperature that prevented ecosystems from stabilizing. Just as life would start to recover, another pulse of volcanism or a release of methane would hit, knocking it back down. It took nearly 10 million years for complex ecosystems to fully return. This period serves as a grim reminder of how delicate the balance of our biosphere actually is. It shows us that when the carbon cycle is broken, the consequences can last for geological epochs. The scientific detective story. How do we know all of this? The story of the Great Dying is written in stone. Geologists and paleontologists have pieced this narrative together by studying rock formations around the world. In Meishan, China, there is a distinct layer of rock that marks the boundary. Below the line, the rock is packed with diverse fossils. Above the line, it is barren. Scientists analyze the chemical composition of these rocks. By looking at carbon isotopes, they can detect the massive spike in carbon-12, which indicates a biological collapse and the injection of volcanic carbon. By analyzing biomarkers, fossilized molecules, they found traces of isorenioreitine, a pigment produced specifically by the green sulfur bacteria that thrive in toxic, oxygen-free water. This confirmed the theory of the poisonous purple oceans. The dating of the Siberian traps rocks matches perfectly with the extinction timeline. It is a triumph of forensic science, solving a murder mystery where the victim was almost all life on Earth, and the crime scene is 250 million years old. Reflection. A warning from deep time. Why does the Great Dying matter to us today? Apart from the fascinating history, it serves as a critical analog. The mechanisms that caused the Great Dying, rapid release of greenhouse gases, global warming, ocean acidification, and ocean anoxia, are the exact same phenomena we are observing today. To be clear, the rate of carbon emissions from the Siberian traps was massive, but some studies suggest that our current rate of burning fossil fuels is releasing CO2 faster than the volcanoes did back then. The difference is the total duration. The volcanoes erupted for thousands of years. We have only been at it for a couple of centuries. However, the Permian extinction teaches us that the Earth system has tipping points. Once certain thresholds are crossed, like the melting of methane hydrates or the collapse of ocean circulation, the warming can become self-sustaining and run away. It shows us that the ocean is the life support system of the planet, and when it fails, everything fails. Conclusion. The Great Dying was the darkest chapter in the history of life. It was a time when the Earth tried to kill us, and it almost succeeded. The lush forests turned to rotting slime, the vibrant reefs dissolved into toxic sludge, and the air itself became poison. Yet, life is incredibly resilient. From the ashes of the Permian world, the survivors emerged. The empty world provided a blank canvas for evolution to experiment. The dominance of the synapsids ended, making way for the rise of the dinosaurs, who would rule for the next 160 million years. And eventually, in the shadow of the dinosaurs, the tiny furry descendants of the surviving synapsids, the mammals, would wait for their turn. In a way, we owe our existence to the Great Dying. If the old order hadn't been swept away so completely, the evolutionary path that led to humanity might never have opened up. We are the descendants of the survivors, the ones who endured the heat, the acid, and the darkness. But looking back at that purple ocean and burning sky, We must remember that we are not immune. The planet has changed before, and it can change again. The Great Dying is not just a story of the past, it is a lesson for the future. Thank you so much for watching all the way to the end. If you enjoyed this video, learned something new, or simply want to see more content like this, please give it a like and subscribe to the channel. Your support truly helps the channel grow and reach more people. And if you have thoughts or ideas you'd like to share, feel free to leave a comment. I'd love to hear from you. See you in the next video.